kind of visualize this curve, you can kind of see where your pieces lie. So if we kind of like look at your curve to come out here, in the middle, that's where your mean is. That's where your zero, closest to zero. Your negative z-scores, your positive z-scores. So this is a good like frame of reference. So they asked you where would the z-score of 0 fall? That would be your B, smack in the middle of your curve, right? That would be where your 0 is. Your z-scores go 0, 1, 2, 3, and -1, -2, -3. Okay. A z-score of negative would be to the left of the 0. That would be your A. A z-score of positive would be to the right of the 0. That would be your C. Good? Just to keep it in perspective. I'm big on the sketches, especially in the beginning. What I want you to do is get used to sketching. And everybody always says, yeah, but I know the formula, I don't need to sketch. Believe it or not, you can't believe how many kids will give me on the wrong side of the 0 when they're doing their values. So I need you to sketch so that you see where it is and we keep everything in perspective. Again, we can kind of visualize some kind of curve here coming across. Your 0 would be smack in your middle. There's your negatives. There's your positives. So the only negative is the -1.54. That's your A. The B and the C, well, the one closer to the 0 would be the B, and the one further away would be the C. Can we do this? Yeah? All right. And then you had a little exercise on which one did better, and this was a good one. You had a, oh, I don't even know, where did this come from? Is there a question in here? No. Oh, this is the one I was going to give you in here. Okay, so save this one for a minute. Save that one. I put it in, I meant to put it in at the end, not in the middle. It just came in the wrong spot. Okay, so very, very important that we can do this. I want your mean. I want your standard deviations to go out. And don't say, yeah, I didn't need to do it. I need to see it. I need your 1, 2, 3s. This is what I'm looking for. Your mean goes in the middle. Add your standard deviations up. Subtract your standard deviations down. We have to find a value of what our z-score is when we have a value that's 34,000. 34,000 is going to fall to the left of the mean. It's going to be a negative number. If you forget the formula, and you have to know the formula, this is the only formula really that, well, not the only, but the most important formula that you have to know, and that's this one. If you forget it, it's kind of simple. If you're to the left and you need a negative, you subtract the smaller minus the larger. Smaller minus larger. It's still x minus the mean. Divide by the standard deviation. You can't do it the other way. You can't subtract the standard deviation and divide by the mean. It doesn't make any sense to do that. So the two means you have, you're going to subtract. If I need a negative, I make sure I say smaller minus larger. If I need a positive, I make sure I say larger minus smaller. We divide by the standard deviation, we get the z-score. Z-scores need to be 2 decimal places. Okay? I have a value of 37,000. Oh, 37,000 comes over here, right to the right of the 0. Okay, so when we do this, I should come between 0 and 1. And I did, 0.89. Now, if we look, I didn't ask you to look up your values on these, but if we looked it up, you would in your head say, well, this is more than 50%. Now, the reason we do this too is, I know this part is simple, but the next step after we work with your tables, we say, what's the percentage of being greater than this, less than this? You know, and if it's greater than that, then we have to subtract it from 1, your area. So when you see the graph and you see to the left is bigger than 50, your answer can't be, to the right of it can't be bigger than 50. So it kind of puts things in perspective. 31,000 falls over here, to the left of the 0.
Wasn't it 30,000?
Was it 30,000? Okay. So let's do a 30,000. So we're going to get 30,000 minus 35,000 over 2250. So what's my z-score going to be? 2.22? Thank you. So I'm even further away from that. I'm at the 30,000. Just a little bit to the left of the 30,500. Okay. All right, we gave you, we did those. And then we asked what percentile they're in. To find your percentile, this is where you have to go to your table. So when you do this, in your percentile, look in your table. Now, we did this kind of off of your empirical rule because they don't really use your table yet, but I like to use your table. So they said it was less than 2 standard deviations. So they estimated to be this percentile. We can look ours up. So everybody should have a table. And let's look these up. So negative 0.44. Did we look, we didn't have to look those guys up, just these guys? No. Oh, they just gave us these. They gave us different numbers because they have to correspond to their chart. So using your empirical rule, you are at the negative 2. So your empirical rule, and if you're going to play with your empirical rule a little bit, your plus or minus 2 comes here. This is 95. Guys, listen. Your plus or minus 2 is 95% of your data, approximately. So in this area and this area, it shares 5%. So half of 5% is about 2.5%. So this piece right here is about the 2.5%, 2.5 percentile. Okay, so that's how you use your empirical rule. But you can use your table as well, which is even easier. So you're going to, well, we would have to find your z-score for this, and we know your z-score is negative 2. So look at negative 2 on your table. You're looking at negative 2.0, and you're going to come all the way over here to the 0, 0. The negatives, look at the tops, they go backwards. They go from 0.09, 0.08. The positives go 0.00, 0.01. They go backwards on your negative. So find me what that is. Anybody find it? Negative 2. Follow all the way across to the right-hand side at the 0, 0. And what's that little area? 2, 2, 8. So it's about 2.28 percentile. And why is it different than what we found using your empirical rule? Why isn't it the same? Because why? It's more accurate because your empirical rule says plus or minus 1 is 68%. It's really 68.2. So plus or minus 2 has another little extra in there, 0.4. But we don't. Your empirical rule just rounds and says use this percent. And as Julia said, your table is exactly that. So at 37,250, we find 37,250, that's the plus 1. If you want to know how much is here, you automatically have 50%. From here to here, you would have to say plus or minus 1 is 68%. What's half is 68? 34. So I'm going to do, okay, 30 plus, go ahead, you can go somewhere. 30 plus 50 plus 34 is 84 percentile. There's your 84th percentile. Now, look it up in your table as well. Look up 1.000. This is what I got you used to looking at your table. So, Will, look up 1.00 for me. Because my z-score is 1. My z-score is 1 over here. We're at the 1. So, because we have 2 decimal places, we just say 0, 0. So that you can look in your table. So what is it? 84.13. So, this is your percentile. It's a little bit more accurate than just your grid, than just your empirical rule. because your empirical rule says plus or minus 1 is 68%. It's really 68.2%. 0.2%. So we've kind of got a 1% on there. So just a little bit more accurate. This guy is right at your mean. Isn't your mean half of your data, half of the field of your data? 50% to the left, 50% to the right. Be able to look these values up. Okay? And your last one, again, I want you to lay out your graph. 33, add 4, subtract 4, and find your z-scores. Now, they use their empirical rule to find these. Let's find your area using these. Let's find your percentile for these guys. This wasn't on your homework, but we're going to find your percentiles for those. So take a minute and find me what percentile a z-score of 0.25 comes out to be. 59.87 percentile. Did everybody get this? You need to be able to look it up in your table. You have two sides. You have the negative side, you have the positive side. That one doesn't fall nicely in between anything. The ones they gave you, yeah, they fell pretty nicely. You can use your empirical rule or you can use your table. Do you see how your table relates to your empirical rule? It just gets it a lot easier. You don't have to take half of anything. You don't have to divide anything. You just go right to your table. So negative 0.75 is right here. What percentile is negative 0.75 in? 22.66? Okay, and how about 2.25? 98.7, good. Percentile. So are we good with the percentiles? Thank you. Okay. Thank you. Everybody stares blankly at me. Okay. This little guy that I put in here, this is what I was talking about yesterday. You have two tests, and your score, I have no score. So your score depends on how the class did on the whole test. So your statistical mean for your stat test mean was 63. That means the average grade for that test was 63, with a standard deviation of 7. You got a 65. You just barely passed. Your biology test had a mean of 23, with a standard deviation of 3.9. You got a 25. No one passed. Which class, prospectively, did you do better in? Obviously, you did better by passing, but which one did you do better in? That's how we look at your z-scores. You come home and you say, I got a 65. The whole class average was a 63. I got a 65. You come home, you say, I got a 23. The whole class average, I got a 25. The class average was a 23. So it still looks like you did 2 points higher, but which one did you actually do better in? So if you find this z-score, and you find this z-score, you're going to compare your z-scores. So this half of the room, work on the statistic test. That half of the room, find me the z-score for the biology test. We don't need to do it. We need to. I want to see the z-scores. You get, no, you're in the middle row. You get the time off. These guys have to do one. They get one. You can check both their work. You can choose your row. Tell me what your z-score was. Both of them fall within one plus or minus 1 of the mean. So both of them fall where their score should fall.
About 0.28 or 0.29.
Are you doing this one?
Yeah.
Okay, how about this one?
0.51.
9.51?
1, 2.
So which one did you do better in? You were just a little bit better in the biology in perspective to your field. Do you still look better when you pass the test? Yes. But because of the way the class did, you were still in the plus or minus 1 for both of them. You're still where the normal curve is. But your z-score was slightly better in the second one. Whichever one has a slightly better z-score, isn't that the higher percentile? So what's the percentile for this guy? Let's look at percentile. Maybe that'll make more sense. Look in your chart and find me the percentiles for them. 0.29. 61 percentile? About? How about this guy? What is it? 69? 69.5 percentile? So you had a higher percentile in your biology test. You did badly in it, but the class did so badly in it, you actually had a higher percentile in there, right? A higher ranking in that class. So you're pleading with your parents, is, but Mom, I did better than most of the class. I was in the 69th percentile. And even though I passed that one, I was only in the 61st percentile. So do you see how we use your z-scores to do this? Questions at all? No, of course not. Okay, it's not a lot. It comes from 2.4 and 2.5. So I need this done and your vocab. Okay.